Okay, welcome to question 8. So that's the equation you need to differentiate. So we're going to use power rule. Okay, so I'm sure you're familiar with power rule. So that's going to be 1 times 3 and then x 1 minus 1 1 minus 1, and then that's going to be minus, bring 2 that side, it's going to be minus 2 or minus bracket 2 multiplied by 5, and then x exponent 2 minus 1. So that's going to give us 3. That's x to 1 minus 1 is 0, x to the power 0 is 1, 1 times 3 times 1 is 3, and then 2 times 5 is 10, and it's 10x. Alright, so the next thing we're going to have is we have g of x. There is 2x to the power negative 2, and then that is x to the power 7 over 3, so that's power over root. So the derivative is going to be negative 2. Okay, that's multiplied by negative 2 and then multiplied by 2, and then x gonna be negative 2 minus 1, and then the same thing, bring the fraction down, so it's going to 7 over 3, x to the power 7 over 3 minus 1, but 1 we can make it as 3 over 3, that's going to be 1, and then we're going to have negative 4 x to the power negative 3 minus 7 over 3, x to the power 7 minus 3 is 4 over 3. So that's our final answer. That's for g of x. Okay, so that's what we have. So let's look at the steps with step 1. And with step 1, we rewrite the equation. Step 2, we use the power rule. Step 3, that's a simplified version. And then we move on to 8.2. 8.2, we have derivative of x, so we're going to derive the equation there using power rule. F of x is going to be 3x to the power 2 minus 4 times 2 is 8, negative 8x, and then plus 2. Alright, and then we know that's gradient and add 2, so that is the first derivative, which is equation for the tangent, and then using the first derivative, substituting x for 2, and then we have 3 bracket 2 to the power 4 minus 8 bracket 2 plus 2. All of that will give us the gradient. Okay, so simplifying that would be 3 multiplied by 4 minus 16 plus 2, and that will mean that we have 12 minus 16 plus 2 is equals to 14 minus 16 is negative 2 as our answer. So our gradient is negative 2. So we found our gradient. So now we need to know for the curve, what is the y value when x is 2. So we substitute 2 in the original equation, so that's going to be 2 to the power 3 minus 4 bracket 2 to the power 2 plus 2 bracket 2. Okay, so plus 3, so that will give us to the power 3 is 8, and then 2 times the power 2 is 4, 4 times negative 4 is negative 16, 2 times 2 times 2 is 4, and then plus 3. And then from there we use positive together. 7 plus 8 is 15, and we have negative 16, so that will give us negative 1. And thereafter we have the point on the curve, which is x is 2. When x is 2, our y is negative 1. So that is it. So our y is negative 1, and then from there we have the equation of the tangent, which is straight line, is y minus y1 is equals gradient bracket x minus x1. So the coordinate at p is x1, y1, x is 2, and y is negative 1. So we substitute the equation, so that means that our gradient is that and our value is on the point. So y minus bracket my y negative 1 is equals to negative 2, which is our gradient, multiplied by x minus 2, so which is x. Okay, so I think it's gonna be y plus negative terms. Negative 1 is positive 1, and that Lagrange negative 2, and then that term is that is negative 2x, and then that term is that is positive 4. So what we have is y is equals to negative 2x plus 4, and we take 1 that side, so plus 4 minus 1, that will give us y is equals to negative 2x plus 3. So that is our equation. So let's recap. We go through there calculating our steps, just a review. Step 1 there, we derive the equation using power rule. 2, we substitute the value x, where x is 2. We find that our gradient there is actually negative 2, and then step 4, we simplify further with the curve where x is 2, and 5 we substitute in the equation. 6 is our really equation, so y minus y1 is equals to gradient multiplied by x minus x1. 7, we simplify further. 8, further simplification, and gives us to the final answer. So let us go to exponent 3. Given the function f of x is equals to negative 6x squared, and then derivative using the first principle is equals to limit as h approaches 0. We have the function f bracket x plus h minus the original function. So that means the function changes signs on the second step, and all that over h. And that will mean that, okay, so we have f of x there. We have f of x as negative 6x squared, and then we have a derivative x of x plus h, that part there, x plus h, which means wherever there's x we put x plus h. There's negative x bracket x plus h, all of that squared, and that will give us negative 6 bracket, that will be x squared plus 2x h, and then plus h squared. So multiply all that by negative 6, giving us negative 6x squared, and negative 6 times 2 is negative 12xh, and negative 6 times h squared is negative 6h squared. And then next we're going to find that part which is negative the function expression, so it's negative of the f of x, so it's going to be negative bracket negative 6x squared, so the sign changes to 6x squared, so from negative 6x squared to the positive part. And now limit, so what we're going to do, we're just going to substitute there, so that part there becomes this part. So you're just gonna put that part there, which is negative 6x squared minus 12xh minus 6 h squared. So that part where the sign changes of the function, so it's positive 6x squared, so positive 6x squared. All that over h. So the negative 6x squared cancels out, and then we have limit. So we also factor out the h, so it's going to be limit h in bracket into negative 12, not 12, it's going to be 12x. It has to be 12x, yes, negative 12x minus 6h, all that over h bracket 1. So the h cancels out, so now we have negative 12x minus 6h, and then h is 0, so minus 6 where h is 0, that will give us derivative according to the first principle is going to be negative 12x. So you can also use the power rule to prove that it's correct. So first step, second step, third, fourth, fifth, and sixth. Then the first step there, we have the equation for the first principle. Number 2, we first have equation itself. Number 3, what we do is substitute x with x plus h. Number 4, we change the sign of the function. Step 5, we simplify, we put in the step 6, we factor out h, and step 7, that's our final answer. So we move on to 8.3. number 8. That's our final answer there. 8.3.2, they said write down how you will restrict the domain, and then we have the original equation there, which is negative 6x squared, and the inverse there would mean restrict the domain. So for the inverse, so let us see the inverse, how it looks like. So we just trade in x and y, trading in x and y. So wherever there's y, we put it. Okay, that's the original equation. Y is equals to negative 6x to the power 2, and that means that we have where does y put x, and then where does x we put y. So solving there, simplifying for y squared, that means y squared is going to be negative x over 6. So it's negative x over 6. From that we can conclude that is a square root there, square root, so we can't have a root of a negative, so the x there has to be is less or equal to 0, and that's it. So we did a lot for question 1, but then it's going to help us in the next question, where it says that we have to determine the equation of the inverse in terms of y is equals to, so we take the equation there up, y squared is equals to negative x over x, and that will mean y squared is equals to negative x over 6, and then we square root both sides, and plus or minus, so that cancels that. Okay, so that cancels it. So we have y there is equals to plus or minus square root of negative x over 6. And again, conditions, x does not have to be greater than 0, so x is less or equals to 0. So that's our equation. Thank you so much for watching, and don't forget to follow, subscribe, and this is your teacher Black Hat. Any questions, please leave in the comments.